What's up guys, it's Tech Guru here coming at you live from feed.com/the Tech Guru. We're going to do a video here about a version 1 timer. This is a very basic timer meant to introduce you guys to timers in general. A lot of people don't realize that you can run this timer off of 45, set 27 volts. A lot of people, they build their timers and they use a separate battery for their timer, which always keeps it running. And this has a built-in voltage divider by using 2 resistors. So what it does is it takes any input voltage, cuts it down, and makes it usable for the timer, because you can't run any more than 15 to 18 volts through your 555 chip. So by utilizing this voltage divider, you can cut down 45 volts to 15 very easily. Okay, so let's get started. We'll go through the components on this schematic. We have basically an input voltage of 27 and 45 volts. We have our voltage divider, which consists of R1 and R2, and that'll cut 45 volts down to about 15. R1 is 2K, R2 is 1K, R3 running to pin 7 of our 555 is 10K. That runs in line to a variable resistor, which is R4. That's a 50K variable. And what this part of the schematic means that one of the pins is connected to the other. So the middle pin or the wiper pin is connected to either pin 1 or pin 3. It really doesn't matter. C1 is a 1UF capacitor, electrolytic. It has to be electrolytic. The 1UF is important. You can use anywhere from 15 volt capacitor to a 50 volt capacitor. It really doesn't matter as long as you don't go any lower than 15 volts. The 1UF is the important part. We have our 555, we have R5, which is from our signal out from the 555, and that's a 1K resistor. And then we have R6, which is a 100K resistor, and we have either a normal transistor that can handle up to 60 volts or a MOSFET, anything that's rated for 60 volts and higher. You don't want to go any lower. You can use a relay here. Relay is going to be clicky, it's going to be loud, it's going to give you a bunch of noise. So what I do is I use just a normal transistor. And if you notice, you can use an IRF 520, you can use an IRF 840, just about anything will work here. And then what this means is you just carry on with your jammer as normal. So if we had a jammer here, here's our jammer. This is version 1 jammer I showed you guys a while back. We have our ground and our positive. What this means is you build your timer and then you just take your ground and your positive and you just carry on with it straight from the battery. Okay, so let's go through some of the components on the actual breadboard. You'll notice that this rail right here is the rail we're going to use for our positive input from the batteries. And this rail right here is what we're going to use for our negative input from our batteries. So you just take your battery and hook it up right here, positive and negative. Okay? Of course there'll be a switch somewhere over here so it doesn't just keep constantly running. You'll see from positive, our positive rail to pin 8 of the 555 is R1, which is a 2K resistor. R2, this is R1, it's a 2K. R2 is going to come from negative to that same pin 8. Here's pin 8 right here. And if you notice, the 555 is set up like this: 1, 2, 3, 4, 5, 6, 7, 8. So pin 1, 2, 3, 4, 5, 6, 7, 8. You notice a little notch right here. So R2, which is a 1K resistor, is going to come from our negative, which is right here. You notice a jumper wire from our negative to pin 1. That's a negative from the battery. And that's going to get tied into pin 8. So this is R2 right here, 1 to 8. Notice that. Pin 8 is going to get a jumper wire. You'll notice right here that pin 8 and pin 4 need to be connected together. So you take a jumper wire, which is right here, and you run it from pin 8 to pin 4. That just jumps them together right here. you'll notice this resistor right here. Let's see if I can get to it. And that runs from pin 8 to pin 7. Pin 8 to pin 7. If you look on here, here's pin 8 and here's pin 7. So which one is this? This is R3. That's a 10K. That's tying in, basically, if you see this connection, pin 8, pin 4 get jumped together. R1 from positive, and then R3, 10K. This is a junction for all these. You notice that's why they're all set up that way. So we have another jumper wire from pin 6 right here, and that goes to pin 2. Let's see if we can see it. Pin 6 to pin 2. That's this one right here. If you look on the schematic, here's pin 6, here's pin 2. They need to get jumped together. Here's the capacitor right here. And this is a tiny 50 volt 1 UF capacitor. So it's saying that basically, since pin 6 and pin 2 are jumped together, we need to go from negative, which would be pin 1, right? There's going to be a junction with R2, pin 1, and the negative side of our capacitor. So we find the side with the stripe, which is right here. That's a negative. And we put that into pin 1. And the positive goes to pin 2. See the positive sign? It goes to the pin 6 and 2 junction. See if we can get a good view. Get a close up. Okay, so we've discussed the components up to here. Basically up to here. Now let's discuss, we've discussed the jumper wires that go from pin 8 and 4, the jumper that goes from 6 and 2 to tie them together. Because even though it looks simple on the schematic and they're right next to each other, pin 2 is over on this side and pin 6 is on this side, so you need a jumper wire. Now that we've done that, let's talk about the variable resistor. Okay, so there's our variable resistor. Okay, this is a 50K and it's got 3 legs. The middle one is called the wiper. Let's connect this back in. The middle leg is called the wiper, and you can connect that to either pin 1 or pin 2 and turn it into a variable resistor. This is basically a potentiometer, sort of. And if you notice on the breadboard, I have a jumper wire right here, and that's tying the wiper, the middle pin, and pin 3 together. And that leaves, now what you have is you have pin 1 over here and pin 3. Those are 2 connections that you're going to use. And that's where the jumper wires come in. This is pin 1. This is pin 3. Remember, 2 and 3 are tied together, so this is acting as a variable resistor. And it doesn't matter what side you connect where. So this wire right here is going from pin 1 to pin 6. This wire right here is going from pin 2 and 3 of the variable resistor to pin 7. Very simple. There's a jumper wire that's tying our negative from our battery to pin 1. We need that just to run it over there. Okay, so let's do close-ups up to that point. There's our variable resistor, pin 1 and 3, jumper wire on 2 and 3. There's jumper wire. Coming over here, 7 and 6 from the variable resistor, from the positive to pin 8 is a 2K. From pin 8 to pin 4 is a jumper wire. From pin 8 to pin 7 is another resistor. Let's see if we can get that. Pin 8 to pin 7. That's the 10K. This resistor right here is the 10K, and that would be R3 right there. This is a 1K resistor going from negative to pin 8. As you'll notice in the schematic, pin 1 is negative, right? So this is the negative rail. That's why you can just take the resistor and go from pin 1 to 8. Okay. So our other jumper wire goes from pin 6 to pin 2. And then our electrolytic capacitor goes from pin 1, which is also our battery negative, to pin 2. Very simple. Pin 1 to pin 2. These 2 and 6 are tied together already with that jumper wire. Let's go into R5, which is a 1K. This is like a decoupling sort of resistor. Basically, you don't want to connect directly to pin 3 to your transistor. R6 is basically to shed is there to basically shed any extra voltage or signals back down to negative. Because if you're using a MOSFET, what would happen if you didn't have R6 is it would never shut off. So this R6 right here allows this to pulse from pin 3, and it can pulse a MOSFET if you have a MOSFET there. And then when it doesn't want to pulse, it just any extra electricity or voltages get slammed right back into the negative wire, and it allows the MOSFET to turn off. But this is good practice. So if we look from pin 3 is our output, so R5, it should be a 1K. This is a different type of 1K that I had. You'll notice that this is a 1K, but I used a different 1K for the same from a different manufacturer. It goes from pin 3, see that? Pin 3 to our base, the base of our transistor. I'm using a transistor in this case. You can use a MOSFET if you want. So that's R5 1K. Turns it on by slamming it with signals to the base. There's our R6, which is 100K. That allows it to shed any extra voltages back to the negative when we don't need it. You'll notice right here, this is the emitter of the transistor, and it needs to be tied into our negative voltage from our battery. So what do we have? We have a jumper wire. It goes from our negative rail down to emitter. And so guess what? This rail provides our positive voltage for our jammer, and the collector of this transistor right here becomes our new negative. So what this does is it turns it on using base. Pin 3 turns the transistor on using R5 and R6. It opens up the gap between collector and emitter. The negative flows through the emitter and comes back out the collector. It basically creates a bridge. It's a switch. That's why it's good to use. So we'll just take any wire, go from positive or positive rail, right? Take the same type of wire, go from negative. So now we're ready for a battery. What you want, I don't have a switch here but that I'm going to use, but what you want in line here is a switch right here. Okay, that'll be the switch of your jammer. Now since our collector, let me show you that. Since our collector is now our new negative, we're going to take our jammer. This is an emitter of our jammer, which needs negative. We're going to plug that into the collector. Boom, we got our new negative right there. Nothing changes with the positive voltage. So this is basically just a jumper. We're going to connect the positive voltage to the positive rail. It doesn't have to be like this. You could just go from this wire and tie them together, right? But for sake of making it easy, we're just going to pop it in there. And then what you have, and by the way, you could do the same thing with this. If I were to just snip these off, this is one of my testing jammers that you guys see me. This is version 2. If I were just to snip these off, all I'd have to do is tie in the negative wire to the collector and then the positive wire to the positive. It's the same thing. That's all you do. You take whatever jammer that you're going to build, and collector becomes your negative, and your positive stays the same. It goes from your positive directly from your battery. So let's pop this over here to where we can see it, and I'm going to turn this to its fastest speed. Okay. And by jumping pin 2 and 3, the wiper, which is pin 2 and 3 together, when I go clockwise, the pulses get faster, right? That's why I have it. Now if you were to jump pin 1 and 2 together, when you go clockwise, the pulses will get slower. See, that's why I like turning it clockwise and having the faster pulses. It's basically like turning up the volume. So let's connect this to our positive. Okay, let's connect it to our positive. Let's get a better connection. Alright, and since I don't have a switch, I'm just going to touch this. Okay, so that's as fast as it's going to pulse, and it looks different on camera than it actually looks in person. I can see it pulsing. The camera just makes it look like weird. So now I'm going to turn my variable resistor about the halfway point. So right now we're at 25K. If this is a 50K, I have about 25K. The post is turned in half to the center mark. I'll touch the. And if we go all the way to the left counterclockwise, it'll just turn it. It'll bring this variable resistor down to 0K. And it'll just be fully on. Okay. So let's go about 3/4 clockwise. About 3/4. Let's go as fast as it can go. Now I'm going to go all the way to the right again. Okay, now to me it's pulsing really fast. The camera the frame rate of the camera makes it look weird. And this is still cool. So what you've done Yep, everything's still cool. So what you've done is you turn this transistor into a switch.